Hello team and welcome back to the channel. So in today's video we are going to learn about 𝗖cie𝗂𝗽𝗃 cluster, which means highly available Kubernetes cluster. So I'm going to explain in detail how we can set it up, why do we exactly need that, and how exactly is the best way to set it up on a self-hosted Kubernetes cluster. Okay, so before we get started, I would suggest you subscribe to the channel if you haven't already done, because you will find tons of amazing hands-on videos on DevOps as well as on cloud DevOps and real-time scenarios. So make sure to subscribe. Also, for people who are looking for dedicated training sessions on DevSecOps and cloud DevOps, you can check out batch 6, which has just started, so you can still enroll to it. Links will be in the description. Now with that being said, let's get started. So team, now let us understand about Kubernetes cluster and highly available Kubernetes cluster. Generally, in a self-hosted Kubernetes cluster, we have general structure something like this. We'll be having a master node and worker node where we are going to perform the deployments, right? And this master node is the one who is going to manage the worker node. But let us assume a scenario where some issue occurs in the master node and it crashes. Okay, this crashing of the master node, it's going to take the whole cluster down, because we are having just one master node who was managing multiple worker node, and the master node itself, if it has failed, then it's going to take the whole cluster down, right? Which is a big issue. So in order to solve this problem, what we suggest that instead of using or having just one master node to manage the worker node, we can have multiple master nodes. Okay, in that way, if we are having like 3 master node, then if one master node fails, still there will be 2 to run the whole cluster, right? So let us say in this scenario we can have one master node, second master node, and third master node. Okay, and let us say we can have multiple number of worker node. Okay, who is going, and these worker node are going to be managed by these master nodes, right? Okay, now you can see like there are 3 master nodes. That means even if one fails, still there will be 2 for decision making, and they can like make the cluster up and running, right? One more thing, one concept that we need to understand, which is known as quorum. Okay, sorry about spelling if it's wrong. So basically quorum is the number of minimum master node that is required in case of highly available cluster for decision making. For example, here we are having a 3 master node. So what is the minimum number of master node that is needed for decision making? Okay, so for this we have a formula n by 2 plus 1, and we are going to apply floor function on this. Okay, that means n is going to be total number of worker node, master node by 2 floor function plus 1. That means here we are having 3 master node, right? 2, it comes to 1.5. When we apply the floor function, it comes to 1, because 1 is the lower side nearest whole number. Okay, then as per formula 1 plus 1, it comes to 2. That means in case if you are having 3 master node, then in that case you should be having you need minimum 2 master node for decision making, right? That means even if master node 3 fails, still we'll be able to run the cluster. Similarly, let us say we are having a Kubernetes cluster where we are having 5 master node. Okay, so in case of 5 master node, what is the minimum number of master node that is needed for decision making in case of failures? Again, we can find using our quorum function by 2, which is 2.5, and as per the formula, it comes to, using floor function, it comes to 2 plus 1 equal to 3. That means in case of 5 master node, there should be minimum 3 master node available for decision making and making sure that cluster runs. That means in case of 5 master node, even if 2 of the master node are failing, still our cluster will run. Okay, so this is the simple concept of highly available Kubernetes cluster. In simple words, you can understand that we are having multiple master nodes, so that even in case of failure of 1 or 2 master node, we still will be having some master node to run the cluster. Okay, now one question you might be thinking, okay Aditya, we are having 3 master node, how load is managed on these master node? So for managing the basically managing the load on this master node, we are going to set up a load balancer, which is also known as uh, 𝗖cie𝗂𝗃𝗽 load balancer. This we can set up on third machine, and this is the one who is going to manage the load on these master nodes. Okay, and this is the whole thing that we are going to set up. So let me show you the prerequisite for this. First of all, we should be having one VM for 𝗖cie𝗂𝗃𝗽, then 3 VM for master node, and we are going to take 2 VM for worker node. I'm taking very less number of worker node because we just need to test it out, right? So these are the functionalities, and these are the like VM that we'll be needing. In addition to that, there will be certain other like rules we need to define in our security group, which I'm going to show you. Okay, so let me explain you all these things with hands-on. So team, now let us set up our highly available Kubernetes cluster. Before that, first thing that you need to understand that we need to set up a proper security group, and the ports that will be opened are here. Okay, maybe you can take a screenshot because these are the ones that will be needed. Now, in case of these 2380, 6443 and 2379, you need to open the source in specific format which I'll be defining. Okay, this is the kind of subnet in case for our private IP subnet, because the communication between the master node needs to happen properly. Okay, for that purpose we need to open the subnet range here. Okay, so team, now let us create the virtual machines, and one thing you should definitely remember, you have to watch it till end, then only you'll be able to implement it properly. Okay, so now we have to create actually I'm going to create two worker node, 3 master node and 1 load balancer node. Okay, so let us type the number as 6, and I'm going to create the machine as, let's say I'm going to provide the name as just K8. Okay, take the Ubuntu machine, version will be 24.04 LTS version, and size I'm going to go with T2, not T2 large, it's too big. T2 medium is fine actually. Okay, select the key that you are having and make sure you are selecting the this one, the security group, same as the one that I have. Okay, storage just going with 25 and click on launch instance. Okay, come here and let's refresh the page. Okay, so here we have our machines. So first will be HA load balancer for my master node. Second will be master node 1. Third will be master node 2. Fourth will be master node 3. 5 will be worker node 1, and last will be worker node 2. Okay, this is done. Now we need to connect to these machines one by one through MobaXterm, best application for this. So first let's get the IP address of load balancer. Go to MobaXterm, click on session, SSH, IP address, paste it here, then username. We have created Ubuntu, so username is going to be Ubuntu machine, and select the key. So we can browse it on our location, on our local machine, and select it. Let me just rename this to 𝗖cie𝗱𝗲. Okay, color, let me just give it to something like orange. Okay, let us close this. Then second session we need to create, so I'm going to duplicate this and rename this to master node 1, and we need to change the IP address, which we can get going here, master node 1 IP address, this one, and paste it here. Okay, then again create duplicate of it, rename this. This will be master node 2, color, let me change it to blue. Okay, and IP address we need to change. So for master node 2 we can get the IP address here, copy that and paste it here. Okay, similarly for, we'll create duplicate session, rename this, and this will be master node 3. Okay, and remote host, so for that we need the IP address, we can get it from here, copy that and paste it here. Okay, then duplicate session, rename this. This will be worker node first, and we need to get the IP address which we can get from AWS. Here we can go to this one, get the IP address and paste it here. Okay, save this, and one last we have, I'll create duplicate session, rename, and this will be worker node 2. Okay, and last IP address that we can get is going to be this one. Okay, now this is fine, let us close this. Okay, now one more thing that you need to remember, in the security group, the ports, the specific ports that I have shown you, let me show you again. Where is it? Security groups, primary, And here you see certain ports that I've opened. For them source I have decided specific private IPs. Okay, this is a subnet basically. So how we can get this subnet? So basically what you have to do, open any of this, and then you will see the private IP, and you see this first one 172.31. Okay, fix that. Rest you need to make it as variable. That's what I have done here. So 172.31.00/16. Okay, this is a subnet. So for 2380, 2379 and 6443 you need to do this. Okay, coming back here. So now let us start by configuring all these machines. Okay, first we have load balancer, master node 1, master node 2, master node 3, worker node 1 and worker node 2. Okay, first let us get started with load balancer. First command you need to run sudo apt update, and this is the command that you have to run on all the machines first of all. Okay, so let me run this on all of them. Okay, coming back to load balancer machine. Here first of all what we have to do, we need to install 𝗖cie𝗱𝗲. So I'll copy this command to install the 𝗖cie𝗱𝗲 and copy that and run this. Let's wait for this to complete. Once it is done, then we need to do a configuration on this specific file. Okay, and configuration also, this is the configuration that we need to do. Few changes we need to do depending on how many master nodes you are having. You need to add this part. Okay, let me show you. Yeah, this is done. Now we can edit the configuration file for 𝗖cie𝗱𝗲. Sudo vi/etc/𝗖cie/this one. This is the configuration file that we need to modify. Go into insert mode, click enter and paste it here. Okay, now what things we need to modify, you can see master IP, it's written there, right? That means we need to put the IP address of the master node 1 first. Okay, that we can get from here, rename session and get the IP address, copy that, paste it here. Similarly for the second one we are having master node 2, copy that, paste it here, and one more, because since we are having 3 master nodes, so I can copy this thing and yeah, here also we need to change the IP address for master node 3. Yes, sir. Okay, that we can do by getting the IP address here, paste it here, and make sure to change the name here as master 3. This is done. Simply save this. Okay, and we need to restart. Okay, for restarting you can run the command systemctl restart 𝗖cie𝗱𝗲. Copy that. Okay, this part is done. As of now you can see it says no server available, because as of now we have not configured the master node and worker node, right? Okay, next up what we have, we need to prepare all the nodes, master node as well as worker node, using this. What it's going to do, it's going to install docker, kubeadm, kubelet and kubectl, that also the latest version, which is 1.30, right? So I'll copy this whole script and first go to master node 1. Okay, let me make it bigger and let us create one script, 1.sh, paste the contents here, save this, okay, and make it executable by sudo chmod +x 1.sh and execute this. Okay, now whatever commands we have written there, it's going to be executed one by one. Same thing we need to do on master node second. Create this script 1.sh, paste this script here, save this and make it executable chmod +x .sh and execute it. Okay, meanwhile we can check the progress here also. Okay, it's running and here also it started. Same thing we need to do on all 3 other nodes also. Correct. vi 1.sh, paste this script, save this, make it executable sudo chmod +x 1.sh and execute it. Okay, meanwhile checking the progress here. So on master node 1 it's completed, on master node 2 it's still in progress, and master node 3 started, right? Same thing we need to do on the worker node as well, because those tools, kubeadm, kubelet, and kubectl along with Docker will be needed on the worker node also, right? So on the first worker node, create the script, paste the content, save this, make it executable by chmod +x 1.sh, and then execute this file. Okay. And one last thing for the worker node 2. Here also, may increase the screen size. We have to run the command vi 1.sh, paste this script, save this, and make it executable. chmod +x 1.sh and execute it. Okay. So this is being done. Meanwhile, what next thing we need to do? We need to initialize the first master node so that we can get the kubeadm join command, which will be needed for joining the master node together, right? So let me copy this command and let me tell you what changes we need to do. Here in this command, we just need to change the load balancer IP address that we can get from here. If I go here, instance is running. We have this one, right? proxy load balancer. I'll copy the IP address and paste it here. Okay. Once you have done that, just copy this whole command and run this on the first master node. This is going to create a join command for master node as well as for worker node. Okay, and let us run this, and this might take some time. Okay, again I'm saying I'm using the latest version 1.30.3, right? Using Kubernetes version. This is the good thing because yeah, it's better to use the latest version because that is like relevant for quite some time. Okay. So as I said, this might take a little bit of time, so we need to wait for it. Meanwhile, we can check the status here. Master node 2 also we have ran the command for installation of kubeadm, kubectl, and kubelet. Okay. Same thing we have done on worker node as well. Okay. So yeah, so let's wait for this. Now you can see here very clearly we have two kind of join command created. What is written here? You can now join any number of control plane node. What is control plane node? That is the master node. Then you can join any number of worker nodes by running the following, right? That means we can join the worker node also. That means we have the command ready now. Now before we start running these commands, we need to make sure that we are setting up the directory for kubeconfig file. You can see to start your cluster, you need to run the following as regular user. So I'll copy that here. And we need to run these three commands. This is going to set up a folder inside which we'll be having a kubeconfig file. Okay, this is done. After that, two more things we need to do. We need to install 𝗖cie𝗂𝗽𝗍, which will be working as the network plugin. Okay, install that. And one last thing, nginx ingress nginx controller also we are installing. Okay, now let's wait for this. So this is done, right? Now we can go ahead and run the command to join the master node as well as the worker node, right? If you see here, the command join the second and third master node, right? So we can get the commands here, copy that, and let us run this on the second master node first. We can run it using sudo. Okay, and let's wait for this to complete. Same command we have to run on third master node, so I'll run it at the same time so that we can save some time, right? Okay, let's wait for this. And again, on the other master node also we have to run this command to set up the kubeconfig file. Okay, and it's almost completed as I see. You know, even if you see this error warning and error, just ignore it. It's not going to cause any issues. Okay, so let's wait for this. You can see this node has joined the cluster and a new control plane instance was created. This is fine. Now we need to run these commands to set up the kubeconfig file folder. Okay, and this one, same thing we need to do here on the third master node. And okay, this is done. Next up, what we have to join the worker node. And as you remember from the first master node itself, we got the command for joining the worker node, right? Second join command. So I'll copy that, go on worker node, run the command as sudo, this one, And you can see here this node has joined the cluster. That means the worker node 1 is connected. Same thing we need to do for this second worker node, which is going to be this one. And yeah, you can see this is also done. Next step, what we have to do, we can verify the cluster. So first of all, I can copy the command for getting the worker nodes or master nodes, whatever we are having. Clear the screen. I will run here on the first master node, kubectl get nodes. Here you can see 3 control plane is there, 1, 2 and 3. Control plane is nothing but a master node. And these things you see, this roles as none, these are the worker node. As you can see, currently one of them worker node is in not ready status, because when you join them, they take few seconds or few minutes to completely come up in running state. So if I run the command again, it's still not in running status. Let's wait for this, and it should be coming in some time. Okay, let's wait for some time, then only it should be see, as I said, it's going to take few minutes or few seconds also to completely come up in running state, because here we can see that it says that this node has joined the cluster. And okay, let's run one more time. Okay, now you can see it's in running status. That means now we are able to see 3 master node and 2 worker node connected, right? Next up, what we can do, we can do a verification, basically just confirmation that the etcd cluster health is fine. Okay, so for that, what we can do, first we need to make sure that we are installing etcd_ctl. Okay, so I'm going to install it first on master node 1. This is just for verification, it's not mandatory. It's just to confirm for us that okay, these master nodes are connected and they are working properly. Okay, so once you run this, then you have to check the health of the etcd cluster. For that, you can run this command. You don't have to change anything. Why you don't have to change anything? Because we are already using the local host. You just need to make sure that you are running these commands on each of the master node to confirm. Okay, and make sure to run this with sudo, because else you will get the permission denied error. Here you can see is healthy, right here. Secondly, here also we can do by running sudo. Here also it says it's healthy. And last, here we can do, right? Here also it's fine, right? Next thing, we can verify 𝗖cie_𝗱𝗲 configuration and functionality. For that, one small thing we need to do, we need to add this part. Okay, so that, see, once we add this, then we will restart 𝗖cie_𝗱𝗲 and we can access it over browser, and there we can see if master nodes are connected or not, or available or not properly. So I'll copy this first. We can go to 𝗖cie load balancer, and we are going to, let me run this sudo command, sudo vi/etc/𝗖cie/proxy, then this one. Here just go at the end and paste that. Okay, once you do, make sure to save this.
Yes, sir.
Once you have saved, you need to restart your 𝗖cie_proxy. So I'll run the command to restart by using systemctl. That part is done.
Yes, sir.
Then we can access our 𝗖cie_proxy over browser. So for that, I can get the IP address of 𝗖cie_proxy. And one more thing, team, make sure to, if you see very closely here, I'm using a port 8404. So make sure that you have opened that port. Okay, 8404. And you can see the status here. We have the in backend section, we can see 3 master nodes are there. Okay, now that means these are fine. Now what we can do, we can go ahead and perform the deployment. Okay, so for performing deployment, what I can do, first of all, I can go to my GitHub repository, get a deployment YAML file. For that, I'm going to use Board Game. It is one of the applications that I have used quite a lot, and we are already having the deployment YAML file ready. So I'll copy that, go to browser, and let's go to masternode 3. Okay, here I'm going to create the file ds.yml, paste the YAML manifest, save this. Okay, and let us perform deployment from here itself. kubectl apply-f ds. Okay, and you can see it says deployment is done, right? But when you perform deployment, usually it takes few minutes or few seconds to completely come in running state. Then only we'll be able to access our application over browser. Another thing, since we are having 2 worker nodes, so we are not sure like on which worker node currently application is running. So what I can do, I can run the command as kubectl describe. First let us run this kubectl get all. You can see currently the pods are in running status. Load balancer service is also available. Since I am using load balancer type of the service, so yeah, external IP is in pending state, but still we can access our application over browser on this port. Okay, now I can run the command as kubectl describe pod and the pod name, which is this one, right? Copy that, scroll up, and there will be one section as node. Here you can see the private IP address, right? 4282. If I go here, you can see worker node 1 has the same private IP, while worker node 2 is different. That means our application will be running on worker node 1, right? So what we can do, we can get the IP address of worker node 1, copy that, and the port on which it's will be accessible 30520. Okay, so let us try to access this 30520. As I said, this might take few seconds to completely come up in running state, so we need to wait for it. Okay, because see, here we can clearly see that our application is in running state and we are not seeing any kind of specific issues. Yeah, you can see application is running fine, right? So now what we can do, we can properly test the highly available cluster, if our cluster is highly available or not. So for that, what I can do, I can remove the master node 3. That means only 2 master node will be available, and then we can see if the cluster is working or not. That means 2 master node are available for making any decision. Okay, so let us go ahead and do this. So I'll go to this here, instances, and let me remove this, and let us remove master node 3. Okay, I'll just terminate it. It is terminated, and here you can see the status, close connection, right? Now here let us say I'll go to master node 1. I'll run the command as kubectl get all. Okay, let's wait for this, or I can try here also kubectl get all. Here also you can see, we can clearly see that. Okay, here we are having, okay, no issues. Here also you can see that kubectl get all, load balancer there, and pod is also available. Here also we can see the same thing on master node 2, that pod is available, right? Okay, here also let me just refresh it. So team, we can see that application is still running on the same platform, same port, and same virtual machine, same worker node, right? And still here the master node 3 has been disconnected. Still only 2 master nodes are remaining that are managing the whole cluster. Okay, so this is how we can set up our self-hosted Kubernetes cluster, which is highly available, and this is how we can test it out also. Okay, so I hope this video was useful for you and you learned something from it. Make sure to implement it, and it's a very good option that you can implement it, put it on LinkedIn, tag me, I'll be happy to support you there. Okay, so thanks for watching and have a nice day. And also team, as I mentioned that we have just started our batch 6. If you are interested, you can enroll there. All the details will be in the description.